Hello! In this video we will talk about servo motors, what they are used for and how they work. Servo motors are modified DC or AC motors as they have added positional feedback built into them. Using a potentiometer to track the position of the shaft makes it possible to make precise movements. Most servo motors are limited to a 180-degree rotation angle. Trying to rotate the shaft beyond this range may break the servo. Also, continuous servos exist. They work in a slightly different way and allow for continuous rotation. Servo motors are used in a wide array of applications requiring precise movements. For example, industrial antenna positioning systems and hobbyist robotic projects. As is the case for use purposes, also tons of different kinds of servo motors are available. It's important to check that the specifications of a motor suit your needs. Furthermore, check that your power supply is sufficient for the current draw and voltage requirement of the motor. A servo motor has three terminals: power, ground, and control signal. The Arduino can be used to supply power to one servo for testing purposes, but an external power supply is recommended. The control signal can be connected to any pin on the Arduino. To control a servo with an Arduino, we recommend using the servo library. There also exist more advanced libraries with additional features such as speed control. We are now demonstrating the example code sweep. It can be found from the Arduino IDE under File, Examples, Servo, Sweep. You will need an Arduino, a breadboard, a servo motor, and some hookup wires to follow along. Connect the control signal to pin 9 and the power terminals to Arduino's power and ground. Let's take a look at the code. First, we import the servo library and create a servo object called myServo. We also defined a position variable where we store the current position of the servo. In the setup, we use the library's attach function to define what pin the servo is connected to. In the loop, two for loops are used to alter the position of the servo from 0 to 180 back to 0. The servo write function accepts a value between 0 and 180, which is the desired position of the servo. Remember to include small delays to allow the servo to finish moving before a new write is issued. Opening a servo motor reveals a potentiometer and some additional circuitry. We can see how the potentiometer is connected to the shaft of the motor, which allows it to directly read the position. The potentiometer works as a voltage divider, and in our case it ranges between 0.3 and 1.9 volts when the shaft is rotated. The potentiometer and chip implement the closed-loop control system using negative feedback. The reading from the potentiometer is passed to the chip and compared with the control signal. An H-bridge is used to set the direction of rotation according to the difference in the signals. If the two signals differ, the shaft is moved, and if they match within the limits of the so-called deadband region, the shaft stays still. A PWM signal is used for the control. The servo requires 1 to 2 millisecond pulses that are sent every 20 milliseconds. That is with a frequency of 50 Hz. A 1 millisecond pulse corresponds to 0 degrees, 1.5 millisecond pulse to 90 degrees, and 2 millisecond pulse to 180 degrees. That is everything for this video. Thank you for watching and see you in the next one.